Hello, this is Gurumurthy Ramachandran again. And in this unit, I will be describing a piece of software called BSSim, or Baseline Strategy Simulator. The software was developed by Dr. Paul Hewitt, who is an independent consultant nowadays, but he used to work for NIOSH for a long time. When you open up the software, this is the first screen that you will see. And there are several tabs at the top: strategies, options, help, and about. And this software can be downloaded, as I showed you earlier, from this website shown on the page here, www.easinc.co. You notice there is no M at the end, it is just CO. Coming back to the software, what the software does is it provides an interesting view on several commonly used strategies and their ability to detect unacceptable scenarios. So first, what I'll do is, before I launch into running the software, I'll talk about the different strategies being evaluated. So if you just click on the strategies tab, you will see 5 different strategies here. And so the first one is the OSHA strategy. The OSHA strategy is described in the OSHA IH Field Operations Manual. And the data collection for this strategy is described as follows. You first select an exposure group and identify one or more employees that are judged to be typically maximum risk employee. And then you collect one measurement from each. And the data analysis is essentially you calculate the concentration and you calculate the citation threshold, which is essentially the permissible exposure limit times 1 plus 1.645 times the coefficient of variance of the analytical method. So in fact, the error around it is just around the PEL is just the 95th percentile of the coefficient of variance of the analytical error. And so if the concentration that has been measured is less than the PEL, then the exposure is considered acceptable. If the concentration is greater than the PEL times the 1 plus 1.645 times CE, then the OSHA inspector issues a citation requiring the employee to investigate and take appropriate action. And if the concentration is between the PEL and the PEL prime, then there is possibly an overexposure, and therefore you should collect an additional measurement. There is another strategy where it's called the IH company, and here the company IH advocates a strategy based on minimal requirements of the OSHA single substance PEL. And here again, the strategy is to select an exposure group, identify one or more representative employees, and collect one measurement from each. And there is no statistical analysis needed, and we apply the following decision rules. If the initial concentration is less than the action limit, then the work environment appears acceptable. If any concentration is greater than the PEL, then investigate and take appropriate action. And if the concentration is between the action limit and the PEL, then collect additional measurements until 2 consecutive measurements are less than the action limit, or any concentration is greater than the PEL. A third strategy is called the corporate strategy, and here the corporate industrial hygienist IH advocates exceeding the minimal OSHA requirements and recommends using the AIHA strategy, where the occupational exposure limit is equal to the PEL. So here the data collection is described as follows. We select first a similar exposure group or SEG, and we randomly select 6 or more, or 6 to 10 measurements from each of these workers. Or actually, let me just repeat that again. We select a similar exposure group or SEG, and we randomly select 6 or more workers. 6 to 10 is recommended, and we collect one measurement from each worker. In the data analysis phase, we estimate the upper percentile, for example, the 95th percentile and its upper confidence limit of the SEG. And then if the percentile estimate is less than or equal to the OEL, then the work environment is considered acceptable. If the percentile estimate is greater than the OEL, then we need to investigate and take appropriate action. A fourth strategy, consultant A, is advocating using the AIHA strategy, but also notes that the OSHA Pell is over 40 years old and strongly recommends using the ACGIH TLV as the strategy OEL. Otherwise, the strategy is the same as the industrial hygiene corporate strategy. And finally, consultant B believes that nearly any time-weighted average PEL can be interpreted as a long-term average. And so here we start off by selecting an SEG and randomly select 3 or more workers and collect one measurement from each worker. And we estimate the mean exposure, not the 95th percentile, but the mean, arithmetic mean exposure. And if the sample mean is less than the PEL, then the work environment is acceptable. If the sample mean is greater than the PEL, the work environment is unacceptable. So now, having described the different strategies, let me just describe the screen here. What we are going to do is set the parameters of some hypothetical distribution of exposures in an SEG. So we'll assume that the geometric standard deviation GSD is set to be 2, although we have options to change it. Let's assume that the PEL is equal to 10 for this hypothetical substance. And we'll also set the percent exceedance over the PEL to be 25%, meaning that it's a clearly unacceptable scenario if we take the PEL as our occupational exposure limit. We'll also assume that the TLV promulgated by the ACGIH is 2.5, so it's much less than the PEL. And so for this GSD, we will also assume that the exceedance fraction is 90.8% compared to the TLV. So this is the underlying exposure distribution from which the industrial hygienist, using these various strategies, can take various numbers of samples and make decisions. So now what we will do is we will collect one measurement by clicking on this tab. And what this does is it essentially picks a random number from the distribution of exposures and follows the decision rules according to each strategy and makes a decision. And the decisions are shown by these 3 lights here, green, yellow, and red. So the green essentially means that it's an okay strategy, that it's an okay scenario, or it's an acceptable scenario. Yellow means it's still we are still undecided and we need more data. And red means it's a clearly unacceptable scenario. So now let's go ahead and collect one measurement. And this one measurement is less than the PEL of 10 that is shown by the red line here. And the OSHA inspector has clearly made a decision from that one measurement because it is much less than the PEL. So the OSHA inspector says it's an acceptable scenario, even though we know that the exceedance fraction, even if we use the PEL as our occupational exposure limit, it's a clearly unacceptable exposure profile. Then we collect one more measurement, and it's also much less. Now, 3 measurements have been taken, and consultant B in the bottom here has obtained the minimum number of measurements needed to make a decision. The average calculated, the arithmetic average of the 3 measurements is 4.9, and it's much less than the PEL, and the consultant B has also declared that this is an acceptable scenario, even though we know that it's an unacceptable scenario. There are more than 25% of the workers exceeding the OEL. We take a 4th measurement and a 5th measurement. Now you can see that the plant manager who is saying we need to take 1 or more measurements from each worker and then compare the each measurement against the OEL. So now 1 measurement has exceeded the OEL, so the IH plant has declared that this is an unacceptable scenario. And then finally, both these other 2 strategies, the corporate IH strategy and consultant A who uses a TLV, these people have also declared this to be an unacceptable scenario, shown by the red button here. So in this case, there are 2 people, the OSHA inspector and the consultant B who uses the arithmetic average as a decision metric. They are essentially making the wrong decision, whereas these 3 people, they are making the correct decision. Let's reset it again and again run through this exercise. Again, this time we made 1 measurement, and immediately the OSHA inspector and the IH plant, they have declared this to be acceptable because the measurement is below the action limit and below the PEL, of course. Take 1 more measurement and then 3 measurements, and consultant B has also declared that this is an acceptable scenario. So now 3 people, the OSHA inspector, the IH plant, and the consultant B, have made incorrect decisions. In this case, it turns out that even the corporate headquarters that is saying we need to take 6 measurements, but look at the 95th percentile, but use the PEL as our occupational exposure limit, they all have made the incorrect decision. And consultant A, who's using the most advanced, most recent exposure limit of TLV, and using the 95th percentile as the decision metric, has made the correct decision. Let's reset it again. We go through this thing again. So now you see IH every once in a while, depending on the random nature of measurements that we are making from the underlying distribution, a majority of the people, in this case, the majority of the strategies make the right decision. But the OSHA inspector is still continuing to make the wrong decision here. Let's do it one more time. And here now, again, the same 3, the OSHA inspector, the IH plant who's using the PEL and the action limit for a strategy, and consultant B are making the wrong decision. And here, again, by a stroke of luck, everybody is making the correct decision and declaring this an unacceptable scenario. So we can tweak our input parameters and look at how each of these decision strategies play out. And we can say, okay, let's make this 5% exceedance. So it's at the borderline. Actually, let me just make it 1% exceedance based on the PEL, but 37% exceedance based on the TLV. And now let's see how the different strategies do. So clearly, if we say that the TLV is the appropriate occupational exposure limit, then all these other strategies are going to make the wrong decision, as we can see here. The OSHA inspector, IH plant, IH corporate headquarters, and the consultant B, they are all using the PEL and they're making the wrong decision. Whereas consultant A, who is using the AIHA strategy of 6 measurements at least, and the TLV as the occupational exposure limit, makes the right decision. So you can play around with each of these parameters, setting different exceedance fractions. You can also change the geometric standard deviation to make it a more or less variable SEG, and look at the results of random sampling. And the lesson from this that I want you to take is that when we randomly obtain a few samples, and most of the strategies call for just 1 or 2 samples, maybe 3 at best, except the AIHA strategy used by the corporate headquarters and the consultant A. They are typically going to lead to wrong decisions. And consultant A is typically the only person in these simulations that most frequently makes the correct decision, because consultant A is using a strategy that is based on the AIHA exposure assessment strategy, and also using the most up-to-date version of an occupational exposure limit, namely the TLV, or the threshold limit value. Thank you.